Swayam Prabha. Digital India. Educated India.
Welcome back. Let us continue with the problem which I was doing in the part 1 of the lecture number 26. So this is part 2. So it will be the continuation of the previous problem, design problem. So at the end of the part 1 of this lecture, we have calculated the product load. So this is where I had stopped, 64.3 kilowatt. Now next let us calculate the infiltration load. Infiltration load, that is QI. The volume of the room should be known to be calculated. Volume is equal to the length into width into height. So the dimensions are given. This is the dimension, 10 by 13 by 7. 10 by 13 divided by 7. So it comes to volume is equal to 910 meter cube. Next, we need to take the value of the air changes per 24 hours or per day from the table in order to calculate the volumetric flow rate of the. So from ISRE cold storage design guidebook, cold storage design guidebook. Let us refer the table number, that is table 2.9. So this is for greater than 0 positive temperature application. These values are for negative temperature applications. So here also it is same, greater than 0 degree centigrade. So here it is below 0 degree centigrade. This is volume in meter cube. Here also it is volume in meter cube. And the values are air changes per 24 hours. So the calculated volume is 910. So the nearest value, nearest value to 910 meter cube is this value, 1120. We should not take the value of the middle column if it is that is only for positive temperature application. So we are designing the cold storage for negative temperature application. So the value have to be taken from the third column, either in this table or in this table, according to the calculated volume. So this is below 0 degree centigrade, that is negative temperature application. So here also, so I will be taking the value from here. We should not take the value of 2.3, that is applicable for positive temperature application. That's what I have written here. Table number 2.9 corresponding to 910 meter cube. Since we don't have 910 meter cube, the nearest value is 1120 meter cube. The air changes per day is 1.8. Corresponding to 910 meter cube. In the table it is, I think it is 1136. The volume is 1120. 1120. 1120 meter cube in the table. The air changes per day is 1.8. Therefore, volumetric flow rate capital V is equal to volume multiplied by air changes per day or 24 hours. 24 hours. So this is equal to 910 into 1.8. It comes to 910 into 1.8 comes to 1638 meter cube per day. 1638 meter cube per day, which is equal to 1638 divided by 24 into 3600, so which comes to 0.019 meter cube per second. .019 meter cube per second. Now we can calculate the infiltration load Qy, that is equal to density into volumetric flow rate into enthalpy difference. For this problem, the enthalpy of air is given, H1 and H2 are given. This is the outside air enthalpy, H2, and this is the inside air enthalpy, H1, 49.9 minus 25.5. H2 is equal to 49.9 kilojoule per kg. H1 is equal to minus 25.5 kilojoule per kg. Both are given in the problem, given in the question. So substituting the value, density is 1.23, volumetric flow rate is 0.019, 49.9 minus of minus 25.5. Sometimes in psychrometric chart, when we are using the psychrometric chart, in case if the values of enthalpy are not there, there are empirical relations with which the enthalpy of the air can be determined. So now this is equal to, it comes to 1.8 kilowatt, 1.8 kilowatt, 1.8 kilowatt. So this is infiltration load. Next, we have to calculate the equipment load. Let us see the question. How many fans are in operation? Number of fans, 3 fans of each 1.5 kilowatt. The fourth one is equipment load, QF. Number of fans multiplied by the connected load in the refrigerated space. So before that, let us take the value of the connected load in refrigerated space from the table. From ISHRE Cold Design Guidebook, table 2.12, corresponding to 1.5 kilowatt. This 1.5 kilowatt power rating is given in the question. The connected load in refrigerated spaces let us go to the table 2.12. This is table 2.12. Motor kilowatt, and this is the column which we have to refer, connected load. It is given 1.5 kilowatt of, that is the fan power. 3 fans are used. 1.5 is here and the connected load is 1887 watts. This is in watts. It is in watts. 1887. 1887 watts. Now QF is equal to number of fans into connected load in refrigerated space. Three into 1887. 1887. So multiplied by 3, we get 5.7 kilowatts. QF is equal to 5.7 kilowatt. Now we have to calculate that is the sixth load. Occupancy load. It is QO. For this, I will be using the table number 2.13. Table number 2.13. The storage temperature or the room temperature is minus 20. This is minus 20. The heat equivalent per person is 390 watts. 390. This is given in watts. So 390 watts. So that's what I have written here. From ISHRE handbook, this one corresponding to room temperature of minus 20, heat equivalent per occupant is 390 watts. From ISHRE cold storage design guidebook, table number 2.13, corresponding to from ISHRE cold storage design guidebook, corresponding to the room temperature of minus 20. This is when we are taking the heat equivalent per occupant, we have to take the temperature, that is the storage temperature. If you look at the problem, we should not take the initial temperature, we should not take the loading temperature, we should take the final temperature, only this temperature to be taken, this temperature. So this temperature should be taken when we are taking the value from the table number 2.13. So from the table it is 390 watts corresponding to minus 20. Here it is room temperature. This is room temperature in degree centigrade. Heat equivalent per occupant 390 watts. So therefore, occupancy load is equal to number of occupants into heat equivalent per occupant. Number of occupants is given in the question. Number of occupants is 5. So it should be 5 into 390 watts. Q naught is equal to 1.9 kilowatt. So 5 into 390 watts. So that is the value I have taken from the table, 1.9 kilowatt. Lighting load, next one. So that is QL. So directly we can write the formula. QL is equal to lighting intensity multiplied by the floor area. Floor area is nothing but length into width. So lighting intensity is given in the problem 8 watt per meter square. So the length is 10 meter, width is 13 meter. So 10 by 13 will give the floor area. 8 into 10, this is length into width, 10 by 13. So the lighting load comes to 1 kilowatt. 1 kilowatt. 1 kilowatt. The total load Q is equal to the summation of transmission load plus product load plus infiltration load, equipment load, occupancy load and lighting load. There are total 6 types of load. So transmission load is 4 kilowatt we have calculated. So this is 4. Product load is 64.3 kilowatt. Infiltration load 1.8 kilowatt. Equipment load 5.7 kilowatt. Occupancy load 1.9 kilowatt. So this is 9. And lighting load is 1 kilowatt. When we add, the total load comes to these are total 6 loads are there. It comes to 78.7 kilowatts. 78.7 kilowatts. Considering a safety factor of 10%, therefore total load Q is equal to 78.7 into 10% is 110 by 100, 1.1. So that comes to 86.6 kilowatt. Now the compressor running time per day will be given in the problem, or we can assume about 18 to 20 hours per day. So it is given in the question. Compressor running time of 20 hours per day. 20 hours per day. For a compressor running time of 20 hours per day. So this is given in the problem. The total refrigeration load refrigeration load is Q is equal to 86.6 multiplied by 24 divided by 20. So it comes to Q is equal to 86.6, that comes to 104 kilowatt. 104 kilowatt. So this is the capacity. In all the design problems, whether it's a cold storage design for a positive temperature application or a negative temperature application, when it comes to negative temperature application, whether it is pre-cooling, so without pre-cooling or with pre-cooling, out of the 6 loads, that is the transmission load, product load, infiltration load, equipment load, occupancy load and lighting load, the product load contributes to major portion of the total refrigeration load product. So if you see this one, the total load is 78.7, out of which the product load is 64.3. 64.3. So which is more than 75%. 70 to 75% or 80% of the total load is contributed by the product. So to summarize, we have used certain set of tables, like for example, table number 1 is used to find out the thermal conductivity of the insulating material. Once we know the material, we can select the K value. Then table number 2.9, it is used for finding the air changes per hour. Let me show the tables. 4 tables are used. So this is table number 2.1, which is used to take the value of K value. And next table is used is for calculating the infiltration load, volumetric flow rate. Table number 2.9. Then table number 2.12 for taking the value for calculating the equipment load, that is the load due to the fan motor. And table 2.13 is used to take the value of heat equivalent per person or occupant. And lighting intensity, normally it is assumed to be 7 to 10 watt per meter square. If it is not given, you can take any value from between 7 and 10 watt per meter square. So with this, the design of the cold storage, especially in this lecture which we did for the product meet, is completed. Thank you.